Hello, and welcome to the Masterclass series. My name is Laurence, and I'm a PMM at Blocknative.
Hi, I'm Julio, Director of Content and Education at Blocknative.
And we first wanted to start out and say congrats on the merge. We all witnessed last night as Ethereum went from proof of work to proof of stake, and this was a huge step in the right direction for scalability, and we are really excited to be a part of it. Woohoo! And with that, warm welcome to the Mempool Masterclass. In this three-part series, you'll become an expert in the Mempool, and each of these classes will build on the other. Just so that you know, we'll be sending out the slides and recording after, so you can focus on listening and learning. Today, we'll be covering Mempool Monitoring 101. Julio will first go over what the Mempool is, and then go hands-on with Blocknative's Mempool Explorer so that you can get that full experience. Please put your questions in the chat. We'll do our best to get straightforward questions answered via the chat, and any of the more comprehensive ones we'll save to answer in Discord so that nobody misses the answer and everyone benefits. So Julio and I both work at Blocknative, where we have been working on real-time Web3 infrastructure. We focus on the pre-chain layer, which is often overlooked, but really critical, as you're going to find out today. Over the last 4 years, we've been collaborating with some of the best networks, wallets, protocols, and dApps to make our infrastructure the best in class. And we have a really wonderful dedicated infrastructure team that allows us to have unparalleled visibility into a comprehensive set of mempool data, which you're going to learn all about. And that's powering all of this so that you can get an amazing view of complicated infrastructure. All of this wouldn't have been possible without great discussions and knowledge sharing with key players. And we really, really hope that this masterclass is the beginning of that journey for you. And this is the start of many fruitful conversations. And with that, I will pass you to Julio.
All right, thank you, Laurent. So we do have a lot to cover today, so I'm going to go through this stuff pretty quickly. We have my amazing colleagues, Laurent and Emily, ready to answer any questions you might have in the chat. All right. So before we start with the mempool, I want to get started with the fundamental understanding that all transactions, regardless of type, not just blockchain, but in the fiat world as well, involve incredible complexity. So every day we scan our credit cards, we swipe them, we put them in online, and in just a few moments, the transactions get cleared. And I always ask people, hey, have you ever thought about what happens when you swipe a credit card? What's going on while you wait? And I'd say about 99.9% of people say, no, I've never really thought about it. And that's actually really interesting because it turns out there's a lot of there's a lot of really complex things that go on behind the scenes. There's at least 6 different commercial entities involved in credit card transactions. This is an example of Visa's 14-step process for confirming a credit card transaction. And it's pretty amazing because it's not very transparent to the typical consumer, right? All of these amazing things happen in the background, and they're happening globally. There's fraud checks, verifications, merchant checks, consumer checks, and all of this has to happen before your transaction ever gets settled. So it's basically all happening in a few seconds without any awareness from the users. Same thing, by the way, is largely true for any equity trades. So you can see your favorite, if you're using your favorite traditional stock trading applications to buy some Amazon, for example, this would be that flow. This was taken straight from the SEC, and it shows all of the various parties who are involved in every single stock transaction. So you have several different entities with several different flows going several different ways. And I share these two because, hey, we live in the world of blockchain, and we're here to talk about blockchain. So here is a very simple, straightforward interface from Uniswap. And when I click transact, I wait a little while, and then what happens, right? Turns out a ton of complexity as well. Crypto transactions also have a lot going on behind the scenes. Now, transactions in general are inherently complicated, and blockchain transactions are no exception to this, right? Each type of transaction requires a different process. There's different entities involved, different sets of concerns. And so blockchain just represents new types of transactions, which represent new sorts of concerns. And that's what we're here to talk about today. right, so this is a snapshot of the current Ethereum network a few days ago. So technically pre-merge, I know, but I did check it again this morning and it wasn't all that different, to be honest. So the time I took this, there were about 7,261 unique nodes that were part of the Ethereum network. And every single one of those is part and party to your Web3 transactions in this world. And that's just because of the way that the 7,200 plus nodes are involved with the mempool and therefore your transactions. So what is the mempool? Well, at a high level, the mempool is a gateway to the blockchain. Before anything can be written on a block, it first has to move through the mempool. Unfortunately, this important piece of Web3 is often overlooked. But before we go into the formal definition of the mempool, I do have a quick polling question if Florence can set it up. What is the mempool short for? Oops, move that out of the way. What is mempool short for? Is it meme pool, temporary pool, memory pool, memo pool, or none of the above? We'll let this go for, let's say, like 10 seconds, Lawrence.
That sounds great. All right, ending the poll.
Okay, let's see what people said. Okay, so it looks like, okay, 88% people said memory pool, 8% temporary pool, and then 4% said meme pool. I like that. I really wish it did stand for meme pool. If there exists a meme pool, please add me to it.
Me too.
So mempool is actually short for memory pool. The term itself, mempool, actually comes from Bitcoin, and it refers to the set of in-memory data structures inside of a node, and those structures store candidate transactions before they're mined, or I guess I should now say validated, right? So in this presentation, we will focus on Web3 and the Ethereum ecosystem. As such, I'd like to point out that Geth doesn't call it a mempool, it actually calls it a transaction pool. And then Open Ethereum calls it a transaction queue, if I'm not mistaken. But regardless of the name, it's a pool of transactions sitting in the memory, waiting to be included in a block. You can kind of think of it as a waiting area or a waiting room for unconfirmed transactions. Here's a more formal definition for you if you want it. A cryptocurrency node's mechanism for storing information on unconfirmed transactions. So when we think about the mempool, there's sort of 8 key things you need to understand. Number 1, mempool equals pre-consensus. So the first thing that people find very disorienting about dealing with mempool data is it is by definition pre-consensus. It's the place where transactions go while they're waiting to be confirmed, as the network basically forms consensus around which transactions to be included in the block. Because the mempool is before any of that happens, it's literally pre-consensus, which basically means no consensus. Which brings us to number 2. There is no single mempool. What does that mean? It means there's no single mempool truth. There's just many unique copies of the mempool, all of which are slightly different with slightly different characteristics. As such, many of the rules that we expect around blockchain transactions don't actually apply to the mempool. In fact, the opposite rules apply, which could be really very interesting, but also unfortunately very disorienting for a lot of folks that are just new to this space. Okay, so if there's no single mempool, where are all these multiple mempools, right? And why do people call it the mempool if there's more than one? Well, we often talk about the mempool because it's easier than saying anything else. But in reality, earlier when I showed you guys that 6,000 plus nodes on the network, that means that there's 6,000 plus unique mempools because each node has its own mempool, and each node's mempool is different than the nodes around it. Sometimes that can be a little different, sometimes that can be a lot different. As a result of those differences, we have number 3. Each mempool has its unique set of transactions. Now, if you submit a transaction directly into a node, the node will inspect it, it'll insert it, and it'll broadcast it to its peers. And so what basically happens is all of the nodes on the network create these peering relationships, and they share pending transactions with each other, basically across different mempools. And there's all sorts of interesting characteristics and rules that apply to how transactions get propagated against these networks, which nodes accept which transactions and why. For example, nodes can do things like drop transactions, or they might reject a transaction that other nodes have accepted. So when you ask the question, what is the status of my pending transaction? The honest answer is you have to ask like 1,000+ unique nodes on the network to give you a good answer. And you can't do that. It's actually really hard to access them all. So anytime you're figuring out the status of your pending transaction, it's kind of a best guess about what's going on. And most of the time that guess is pretty good, but under specific network conditions, that guess could actually be quite inaccurate. So just realize that any node that you operate, any node that you have access to, and even any network of nodes or set of nodes that you have, only have a portion of the mempool and only have a limited view into all of the transactions that are pending in the mempool at one time. And this is very disorienting for people because they're used to there being some one universal truth on the blockchain. And that's true for the blockchain once things are confirmed. But prior to things being confirmed, there's a whole bunch of weirdness that can happen. Okay, so number 4, each mempool has its own unique characteristic based on client type, configuration, and peers. Now, significantly, nodes are not atomic units. They're just computers running software, right? And significantly, that software can be of different client types. Now, the 2 primary client types on Ethereum are Geth and Open Ethereum, but there are others, and those 2 client types behave differently as it relates to mempools and mempool data. So you actually have some really some interesting variance between nodes based on the clients they run. And then both of those, and all clients really, can have various configurations. They exist on different classes of hardware with capacity to have different settings associated with them. So a node is deployed on, so how a node is deployed on which hardware and which configuration is going to greatly affect how the mempool behaves. And then finally, I want to add each node. Let me move this real quick. Okay, so each node has a set of peers by default. I think the peers are about 20, but they can go up to maybe like 100. And those peer relationships actually change quite a bit on the fly. So which transactions you get in what time frame and what order is also a function of peer relationships your nodes have on the network. So you have all these degrees of freedom, and it affects the mempool actually looking at one part of the network. Number 5, so we talked about how blockchains are immutable. Well, the mempool is the opposite, right? So the mempool is totally immutable. Any pending transactions in the mempool can be replaced with replacement transactions. These are most often things like speed ups and cancels, but there are other replacement types. And so any transaction that's in the mempool can actually be overwritten by the originating wallet at any moment. And so just because it's your transaction is pending in a certain state doesn't mean that that's the state it's going to end up at. You can zero it out, you can cancel it, you can add gas to it. That's a speed up. You can actually change any parameters as long as you reuse the nonce and you add more gas. So you can actually have a single transaction, right, that can exist on multiple states inside the mempool simultaneously, which gets to be kind of interesting because you have your transaction existing on one state and certain nodes, but maybe you replaced it. So then it exists on different states and different nodes. So depending on how your transaction was actually propagated, you can have a transaction that exists in multiple states inside of the mempool simultaneously. And that, if you think about it, that actually makes it quite interesting when you're trying to figure out what exactly is going on with your transactions. Okay, number 6, we like to think about the mempool as this really inconsistent fabric that's lumpy, meaning you have areas of the mempool that have one view of the network and areas of the mempool that have a different view of the network, right? Very similar to what I just mentioned. Sometimes those views are geographically based. So you might have nodes that are in, let's say, Europe that have a different set of transactions than nodes in China. Maybe those transactions are a little different. Maybe those transactions are a lot different. And that's largely due to the conditions of network congestion and mempool pressure, specifically as congestion builds. So as pressure and congestion build, the fabric gets a lot more lumpy, and any one node will start to have less and less of a representative census level view of the entire network during those periods of like high congestion, high pressure. Also, that's unfortunately usually when we need to know the most about what's going on with your transaction, because things are slowed down, gas prices are really high, there's money moving, and you're facing a lot of transaction anxiety. But during congestion and pressure, it can be pretty tricky to figure out what's actually going on. Okay, number 7, your transaction competes in the mempool for block space. Effectively, your transaction is always competing for block space, right? So what do I mean by that? Theoretically, under proof of work, blocks were confirmed on average every like 15 seconds, right? Under proof of stake now it's about every 12, it's not about, it is every 12 seconds. And each proposed block is going to contain typically around 150 transactions at any given moment. But that's usually, there's usually between 80 and 100,000 pending transactions across the entire Ethereum network. So literally every 15, now 12 seconds, your transaction is competing to be one of the top 150 of like 80 to 200,000 other pending transactions. And it's really amazing that any of this really works at all. But that's the nature of it, right? There's all these transactions that are competing against each other to get confirmed as quickly as possible for the lowest possible transaction fee. Which brings us to number 8, our last key. Competition amongst transactions in the mempool actually determine both gas price and time to confirmation. So during periods of heavy network congestion, gas price goes up, and it can be harder and harder for you to get your transaction confirmed in a timely manner. Okay, Laurence, we all good so far? Perfect.
Yes, we are.
All right. Check on the time. Okay, I'm going to try to speed through a lot of this. We're likely to go over the, we're definitely going to go over the 30 minutes. Remember, this is being recorded, so you will get a recording and a copy of the slides as well. So why does the mempool matter to you? Okay, so we've covered what the mempool is, but why does it matter to you? Well, mempool impacts every transaction, every user, every trading strategy, wallet, dApp, protocol, you name it. It's affected by the mempool. But how? Well, whether you're a trader or a developer, you or your users expect your transactions to go through without a hitch, right? You sign your transaction and a few seconds later, it's on chain. Quick, secure, no funny business, right? At least that's the expectation. And it's really interesting because blockchain technology gives users the freedom to transact in ways that that's just never been possible before. Rather than rigid transaction rules defined by and enforced by centralized institutions, Web3 actually enables truly programmable transactions, and the possibility of these programmable transactions really is only bound by a developer's imagination and creativity. And this unfortunately also introduces a lot of unexpected complexity into transactions. So Web3 transactions inherently much more complex than more so traditional transactions that many are accustomed to. And this is because in Web3, users now have the ability to take complete control of their transactions, right? But this control comes with hidden complexities and hidden risks that could prevent your transactions from reaching their intended outcome. Now, why is that? Where did these risks come from? Well, spoiler alert, we are in a Mempool masterclass, so take that what you want. So we've heard of off-chain and we've heard of on-chain. But what about the area between the two? That's what we at Blocknative like to call the pre-chain layer. And in this pre-chain layer, it's in this pre-chain layer that Web3 users need to decide what kind of transactions they want to make. They have to set their own transaction fees, including gas prices and gas limits. They have to understand how gas prices ebb and flow. They need to be able to preview their transactions to ensure it executes the way they're expecting it to. They need to know what to do if a transaction gets dropped or stuck, among a series of other factors. It's a lot to take in. And all of these things I just talked about are affected by the mempool. Even if the mempool, we have a nice little blue line right here, right? So even if the actual mempool is only like this small section after you transmit and you're just kind of monitoring your transactions, right? That's what people probably think, but the mempool actually affects every single one of these steps in the pre-chain layer. For example, when composing a transaction, many traders might be using real-time mempool data to power their strategies, but any information asymmetries can enable a whole host of problems, including front running or any other transaction ordering type attacks. For gas, when you're pricing your transactions, right, network congestion in the mempool, the current makeup of transactions in the mempool determine just how competitive a user needs to set his or her gas prices if they want their transactions to actually be a candidate for inclusion in the next block. When previewing transactions, simulations are held against the current block state to get accurate of transaction outcomes, which means a broad census level view of the mempool is key. Simulating a transaction against a single node mempool would yield like wildly different results. Users can also monitor the mempool during their transaction transmittal process, right, to determine if there are any transaction errors due to maybe like non-scaps, or maybe the transaction is not propagating to the wider network. All of that can be monitored in the mempool, especially if you have a large census level view of the mempool, right? And then lastly, lack of mempool visibility prohibits in-flight corrections. So this lack of in-flight corrections can result in increased user friction from either failed transactions, dropped transactions, stuck transactions, you name it. Fortunately, the path from transaction intent to transaction finality does not need to be linear. What's cool about this is its flexibility enables users to revisit the different phases of their transactions lifecycle to make sure it actually executes as expected. If you, for example, don't like the outcome of your transaction simulation, just go and regas it and run the simulation again. If your transaction is pending too long in the mempool, you can speed it up, right? Resubmit a transaction, same nonce, more gas. But to be really the most successful at all of this, you need the right tools, and you need a low latency census level view of the mempool. Okay, so how does that work? Well, we're going to talk about it. How do you master the mempool? So we talked about the hidden complexities in the mempool and how it affects the entire pre-chain layer, right? Fortunately, Blocknative does offer some really great solutions to help you and your users every step of your transaction lifecycle. Today specifically, we'll be focusing on our transaction monitor, right? And how we can use it to become mempool masters. So our transaction monitor does come both as an API SDK and as a visual interface called Mempool Explorer. And it's that visual interface, Mempool Explorer, that we're going to be working through today. So looks like we might actually doing pretty good on time. So let's get hands-on. Just because we technically only have 5 more minutes, I'm going to rattle through a lot of this really quickly for the sake of time. But like I said, we'll be sure to send you all of this, this entire deck and the recording with all the steps. I have screenshots of everything, so don't worry. And be sure to join our Discord channel as well if you have any questions after the class. Our team can help you there as well. So when you go to explorer.blocknative.com, super easy. You just log in or sign up if you don't have an account. 100% absolutely free to create. So the first thing I want to teach you all how to do is how to monitor addresses in smart contracts. For traders, you might be interested in monitoring your own hot wallet, for example, maybe for instant transaction updates, or maybe you need to send those updates to a Slack or Discord or somewhere else, right? So to watch your own wallet, pretty easy. All you have to do is add your address on this little create subscription section right here. Yes, we do support ENS domains, or you can click, you'll see a card down in the bottom, like right-hand corner. You just click that. It should say, click here to connect and monitor your own wallet address, right? So when you click that, it's gonna open up our really cool user interface for wallet connections. And from there, you just select your wallet and any relevant accounts that you'd like to monitor. Now, for the purposes of this class, I just want to walk you through how to monitor one of the simpler smart contracts. So to do this, just click on the subscription field again. And a bunch of quick start suggestions are going to pop up. Let's go ahead and just click on Tether. And then after clicking on Tether, just like that, wham, you're going to get a feed of all the new Tether transactions pending or confirmed. It's quite a lot of information, and there's a lot of noise you might not care about. So what can we do to clean up that noise, right? So Blocknative offers some really cool advanced filtering, so you only get the information you need. Going back to our example, you can see the little filter button right there. So just click on it and select everything you want to filter out. So in this case, I created a filter by contract call with decimal value greater than 500, and that should update my feed to only show me any USDT transactions over $500. And if you do that, you'll notice it's still pretty noisy. You're still going to get a lot of transactions because there's a lot of people moving over 500 USDT. And there's also still a lot of extra information that I probably don't care about, right, in these payloads. So to do that, I'm just going to click the select option, and I can further clean up this data. So from here, we're going to have a ton of different possibilities. Now, what I selected for this example is I only selected from, to, timestamp, contract call, decimal value, and status. And that'll basically give me a really nice clean feed of who's sending what, where, how much, and whether or not it's confirmed or pending. Remember, all of this is customizable to you and your own preferences to whatever you're looking at. So make sure you tweak this to fit your current needs. So if everything looks good, this is exactly what I want. I can go ahead and save my configuration. That'll give us a whole host of new and exciting features that we can do. Save button, bottom right-hand corner. Once we do that, we can go ahead and create a new API key. And then name it whatever you want. For this one, I named it USDT over 500. And then just click generate new keys and save. From there, you'll be able to go to your account. So if you just click on your name on the top right corner, it'll take you to your account and you can see all of the subscriptions that you have saved. For example, my USDT 500 over 500 that I created is right there. And now that we have that saved, there's some pretty interesting things that we can do with it. So one thing I want to make sure that we go over is composability via webhooks. So I think one of the most popular webhooks, right, is either going to be Discord or you can do Slack. So I went ahead, and Slack is a super popular one. It's fairly user-friendly, albeit slightly more complicated in its newer iterations. But once you create your Slack app, you can set it for incoming webhooks. And then once you receive the address, all you need to do is go to the subscription in your Blocknative settings, and then click the Add Webhooks button. And then you just add the URL from Slack, and you're pretty much done. You'll get a nice little confirmation at the bottom that'll show you that it's active. And then in your actual Slack app, it'll look like this. Nice little feed. There are some other really interesting things you can do. So if you're a developer, you can also export your configuration as a JSON for whatever project you might be building. And that can be either done through this settings page, or everything is accessible also from the homepage of Mempool Explorer. It's just on the left-hand panel. And then last thing I want to cover is ABIs for smart contract monitoring. So Blocknative auto decodes most of the top smart contracts. So we already have the ABIs added. And this just gives you a lot more, a better ability to filter deeper into the contract data. We didn't really need the ABI for this tether contract since it's a pretty simple function that we were looking at, but know that you have the option. You can usually find ABIs on Etherscan. If you look at the smart contract, all you need to do is just save it as a JSON, then you can upload it to Mempool Explorer by clicking the ABI button. And that's pretty much it. That's all I have for you today, Laurence. I can't believe we were able to do it in the 30 minutes. I'm so proud of us.
You did it, Julio. So impressive. So we wanted to, thank you, Julio, so much. That was really, really wonderful. And thank you, Emily. Emily is PM on the Mempool Explorer, who's been answering all your questions. And we want to say thank you for attending. And for us, the Mempool is really important because just like you wouldn't leave your house without checking the weather or using Google Maps when planning a road trip, we believe the Mempool is really this crucial resource for everyone in the blockchain ecosystem, giving you a really clear view of your transaction. So we hope you'll find the Mempool Explorer useful to make more intentional transactions. And we'll be sharing out the deck, the recording, and follow up additional materials through the hashtag Mempool Masterclass channel that we created on our Discord, which the QR code is here. And you can also check out our comprehensive docs. Those are really, really great resource that you can really dive in. And our entire team is on Discord, so you'll be able to get all your additional questions answered there. I know we grabbed a couple that we'll be answering, and we'll send you a few follow-up materials. And just as a reminder, in 2 weeks' time, we have our second part of the Mempool Masterclass series. It is the importance of gas, and that's going to be on Thursday, September 29th, same time, and we'll see you here. We're excited for that one, and it will build on top of what we just learned.
Awesome. There were a few, so there's going to be a feedback poll. I forgot to mention this. So once you leave the Zoom room, it should automatically redirect you to that feedback poll. If you guys can fill that out, that would be super helpful. It'll help us in really making sure that the rest of this masterclass is the best it can be. For POOPs, yes, we will be emailing all of the everybody who is listed as a participant today will be emailed their POOPs later this week. So have a look out for that email. We did have a few questions also that were kind of repeated. So I just wanted to make sure that everybody everybody saw those answered. So people were asking if Mempool Explorer is free. Yes, so there is a free version. Everything that I showed you can be done on the free account. So definitely encourage you all to go in, log in, and play around. Somebody also, there's quite a few.
We've had a bunch of great questions.
I'll be rephrasing them in Discord so that everyone gets that.
Okay, perfect. So
Yep.
Laurent will do that.
I will.
Thank you, Laurent. So be sure to add our Discord so you can see those answers. There's some really great questions in here.
Amazing. Thank you all, and we'll see you in 2 weeks.
Bye, everybody.